Hello everyone and welcome to this Amate Technical channel. So this will be the last tutorial on the structural analysis of the building in ETAB 2020. So before running the analysis, let's see something. I'm gonna show you something before running the analysis. So let's open one file. So here the model is loaded and some notification has been shown. So let's check yes for that. So here you can see our model has been generated. Now let's run the model, and here you can see in the background the model has been run and some error message has been shown. This is because either we have changed the file location part or rename the file. So please don't do that. If you are working in some file, do not copy that file or rename that file. It will it will make the error in the run analysis. When you do the run analysis, there will be some error. So for now, I'm going to close that and let's go back to the ETAB and open the file which we were working previously. Let's open the tutorial one. So here you can see our model has been loaded. In the right side, you can see the 3D view of our frame, and in the left side you can see the elevation. So let's switch this elevation to the plan view. Simply go and click that plan view and select the plan view that you want. For now, we're gonna select it to the story one. So you can see the plan view of story one. So before running the analysis, we're gonna have to do or check something. So we have to check the model. So if all is right, then there will be no problem in analysis. So let's check the model. Select all and click on OK. So it will do the checking in the background. Here you can see in your lower left corner of your screen, the software is processing and checking all the node and frame one by one. So it will take some time, and when it's finished, it will show you a dialog box. Here we have got some warning. So in the meantime, we can ignore this warning because it's not so big deal. So let's close this warning for now. And again, before running the analysis, let's check some load case to run. Here you should keep in mind that your calculate diaphragm center of rigidity should be checked on so that you can get the value of center of rigidity. So click the OK now and run the analysis. So here the software is computing and running the analysis in the background. So now you can see the deform figure in your right side when the analysis is completed. So here you can see the deformed shape of your beam, column and slab. So you'll know that you haven't encountered any problem during the run analysis. So now let's check some data. So let's go to the display and show table. So we're gonna view the display result of load pattern definition of autoseismic user coefficient, modal period and frequency, modal participating and mass ratio, and center of mass and rigidity. This value, we're gonna extract this value. So in the structural output, we'll get the base reaction and modal period and frequency and modal participating and mass ratio. And let's get one more table for the center of mass and rigidity and click on OK. So this is the best reaction value. So you'll need this for computing the foundation. So for now, let's set the model rate and frequency and mass participating ratio. So here you can see in the mode 1 and 2, if you had a mass ratio of more than 40%, that is 47 in the y direction, and in the mode 2 there is 71%. So this value denote that our first two node is in translation, and it's and you can see that this value should exceed more than 40%. So the mass has exceeded more than 40% in the mode 1 in y direction and mode 2 in x direction. And in mode 3, you can see that the value of Ux and Uy is very less, but if compared to this RZ, the value is 87.19. So this denotes that our mode 3 is in rotational. So you have to keep in mind that the mode 1 and mode 2 should be in translation. It should always be in translation. If it is in rotation, then there is some problem with our model. So how do you know that our mode 1 and mode 2 is in translation? You can see that the value of Uy is more than 40%, and when compared to the RZ, you can see the value is very large. So that denote there is a translation in the y direction, and same goes for the x. There is the value of 71%, which is more than some RZ. You can also check that in your code. So go to the class 7.3. So let's scan and go to the class 7.3. Yeah. Here you can see that a sufficient number of modes shall be included in the analysis to include at least 90% of the total seismic mass in the direction under consideration. All modes that are not part of the original load region shall be ignored in model combination. The model combination shall be carried out only for mode with natural frequency less than 30 Hz. Please keep in mind that the mode natural frequency should be less than 33 Hz. So here let's see. So in the mode 4 you can see. So here you can see in the mode 4, the mass participation is more than 90%, that is 92.72. So you have to compare this mode 4 in the let me check it, in the mode rate and frequency. So the frequency in the mode 4 should be less than 33 Hz. If it is more than 33 Hz, then there is some problem with our model. So here you can see the mode 4 frequency is 3.646, which is less than 33 Hz. So here you can see our 90% of the total system mass index under consideration has been achieved in mode 4. And here you can see the value also is correct when you check in the model rate and frequency, where the model 4 is frequency is less than 33 Hz. Now let's check to the drift, that is story response plot. So let's open the Excel file. So first we're gonna check the allowable story displacement. For ultimate limit state, please go and check the clause 5.6.1.1 of the NPC code, where you can, I'm gonna show you that also in the few moment. The clause is 5.6.1, where it is stated that the design horizontal deflection shall be determined by multiplying horizontal deflection found from the equivalent static method or model response spectrum method by the locality factor. So the value is 0.025 at ultimate state, and it should be multiplied by height of the story divided by R mu. So we get the value 553.34. So this value when compared to this software should be more, or in other way, the value that we get from the software should be less than this value, and the same goes for the serviceability limit state. We can check both this value in the clause 5.6.1 and 5.6.3. So let's check the reliable story drift. So maximum storage displacement for the ultimate limit state in x direction is 20.70583. That is in the x direction. You have to note this value. Okay, let's go in the y direction, and the maximum value is 34.882493. So these are in x and y direction. So let's check x and y direction for SLS, that is service limited state, and the maximum value of output in x direction is 90.91553. This is the maximum displacement. Let's check in y direction. The maximum displacement will be 33.5511. So this value I have inputted in my Excel sheet, and you can see all these value we have obtained from this software is less than the value that is stated in the clause of the NVC code. So it is okay. So story our frame is saved in story displacement. So you can also check this by creating a simple Excel sheet. Now let's check this for allowable story drift. For ULS, you can go and find the clause 5.6.3, where the ratio of the inter-story deflection to the corresponding story height shall not exceed 0.025 at ultimate limit state and 0.006 at serviceability limit state. So I have done this both value for ULS and SLS, and you can find that in clause 5.6.3. So now let's check in this software. So let's go to the maximum story drift, and let's go for the ULS in the x direction, and here the maximum value is 0.002717. That is the maximum drift, and let's set that for the ULS for y direction, and the maximum drift will be 0.005014. You have to note these two values, and again we have to check for SLS case also. So let's check the serviceability state in x direction, and here the maximum value of the drift is 0.002614. And again let's go for the y direction for SLS, and the maximum drift value is 0.004823. So here you can see I have inputted these four values for the ELS and SLS state, and all this value is less than the permissible value. So yeah, it's okay. Our model is fine in drift case also. So you can also print this summary report if you want to include in your report. So for now I'm gonna close this report, and let's close this dialog box also. So now let's check the translation and rotational effect that we have discussed in the table. So first we're gonna check for the node 1. This is the bending moment, we don't need this. We need deform shape. So for the mode one, we're gonna check first for first mode. The first mode should be translation in the y direction. You can see that in our previous table where the first mm, mode participation was in y direction as its value was 47. And you have to also bear in note that the first row node should be more than 40% of the mass participation should be there. So if it less, then again you have to revise your model. So now let's check the mode one. So you can see here the translation is in y direction. So let's stop the animation and check the mode 2. And you know our mode 2 value was somewhere between 73 to 80%. So let's check that translation should be in x direction. And you can see our model is translating in the x direction. Now stop the animation and let's check the mode tree. And if you remember guys, the mode tree should have a rotational effect. So let's see how mode participants should be in rotational mode. So yeah, it's taking some time because of the software, but you can see here now the model is rotating. So I'm gonna stop the animation for now. And if you want, you can also check in the plan view. So later on, you can also see the torsional effect by including the minimum torsional and maximum torsional value, and check that if it's satisfied the torsional condition too. So now let's check the moment force diagram. Let's switch to the elevation view. So let's check the member force diagram. So here you can see the moment. So here you can see the maximum bending moment of your beam, and you can also see the shear force diagram and exert force diagram. So here you can see the exert force is larger in the bottom column, and as you move upward, the value slowly get decreased. So click OK for now. So here you can do some more brief research and see all the value you want. So let's go to the concrete frame design preference. So the design code will be IS456 2000. Since NBC code is not included in this ETAB, so we're gonna go with IS456, and the rest is you have to keep in mind that the design for beam capacity should be click on yes. If it's turned into no, we will not get those value. We need those value so that our model is correct or not, to see if our model is correct or not. So rest is okay, so click on OK. So again go to the concrete frame design and see the design combination. So here you should keep in note that if all your design combinations should be on the right side. So in the design display output can get the value of your reinforcement, but before that we need to first start design check. So here you can see all the reinforcement area for the beam and column. You can simply get that value by clicking on the concrete design and go to the display design. So here we get the total longitudinal reinforcement So based on this value, we need to fix the number of the rebar and the size of the rebar in both the column and beam. So let's go for the column for now. I'm gonna open the Excel sheet and click on the column tab. So here I have made one simple tabulated Excel sheet for getting the column area. So this is the required area of steel, and here you can see the provided area of steel, and this is the bar combination. So for instance, let's see the bottom column. We need AST requirement is 1272. So now we have to provide the area more than 1272. So the bar combination of 16 and 12 dia of 4 numbers this will not be sufficient for this. So let's switch bar diameter from 12 dia to the 16 dia, and the total numbers will be 8. So if that will be okay or not, let's check that. Yeah, it's okay. So in this way you can fix the number of column and the size of the column as per the AST requirement. So the same goes for the beam too. So the size of column here I have taken is only 300 by 300, and the AST provided is 1.79%. Sorry, that will be based on the other values too. So these are the rebar combination for the column. So let's switch to the ETAB. Here I'm gonna show you the dimension limit. So dimension limit for the column, we have to check that because the size of dimension we have fixed is 300 by 300. If you look in the code, it specifies another clause 2. So here you can see the minimum dimension of column shall not be less than 20 times the largest longitudinal diameter or reinforcement bar in the beam. So if you compute that, the value will be more than 300 mm, and the clause 2 state that the minimum dimension of column shall be 300 mm, and the third state that the column shall preferably have width to depth ratio of more than 0.45. So let's go to the Excel sheet and check the preliminary dimension. Here you can see, as per the NBC code, the diameter of the rebar we're gonna use for the beam is 16 mm. So based on that, the minimum diameter of columns we need to have is 320 mm, and the minimum diameter of the column is 300 mm as per clause B. So comparing these two values, the dimension of our column should be more than 300 mm. So I have fixed that in to the 14 inch by 14 inch, that is 356 mm. These are the standard size. We can't make the column 13 inch by 13 inch, so our 14 inch by 14 is the standard one beside 12 inch by 12 inch. But for this video I'm gonna go with 12 inch by 12 inch. So even though it is asking us to fix the dimension to the 14 by 14 inch, since this is only for the tutorial purpose, so I'm gonna fix the beam size to 12 by 12 inch instead of 14 by 14 inch. So again, let's see some value, and we're gonna first check if all member is passed or not. If it's not passed, you can again change the size of the column, but since 300 by 300 column is sufficient for this project, as none of the column has failed till now. So let's run the display info and let's check the total rebar percentage. So it should be more than 0.8% for the column. So here you can see already percent is more than that. You can also check this shear reinforcement and the column beam capacity ratio. For the column beam capacity ratio, the class 6.4.4 state that our first let's open the code and then I'll show you something. Here you can see all our column beam capacity is more than 1.2. So again, let's go to the class, and here you can see in the class 4.4.4 the summation of moment capacity for column by beam is more than 1.2. So this should be more than 1.2. If it not, then again there is some problem with our model, so you have to do either increase the column size. And here you can see some information is shown like not applicable. This is because we haven't set the property for this cantilever beam. We have designed this cantilever beam as null frame, so that's why it is giving us the value not applicable. So if you change the property to the beam size, concrete beam size, then some value will pop out here. So let's click on OK, and this in this way you can design the equivalent static for the structural residential building. Thank you for now, and in the next video we're gonna do the detailing of the river. So please do subscribe my channel. Thank you, and see you with the next video.